start recording, and just to say, first of all, welcome everybody to the second webinar in our series.
Welcome everybody. Good afternoon, or possibly good evening or good morning, depending where you are. So the topic for this evening is about the challenge of doing experimental studies, with particular thoughts about science education research, but a lot of this is more general than that. I suppose part of the focus of this is thinking about the nature of research and what might make research be considered scientific. And I suppose research is about the development of new knowledge. And usually we're thinking of knowledge that is to be published, that's become public knowledge. I mean, I think there are real issues about the nature of public knowledge, but that's for another day. I think we generally know what we understand by knowledge that's put into the public domain, the kind of knowledge that's represented in research papers. And if we talk about scientific research, the use of the term scientific could mean we're talking about research in the natural sciences, but it might mean we're talking about research where the approach to research is seen as being scientific, where perhaps we have a scientific methodology, and perhaps where we adopt scientific values. And the real question is, to what extent does this mean our research needs to be experimental? I'm sure most people who are listening to this and watching this have a pretty clear idea what we mean by experiments. Usually we're looking to test a hypothesis of some kind, and that hypothesis tends to be motivated by theoretical considerations. It may be that there's been some observations, but those observations have been conceptualized in a theoretical way that leads to some hypothesis that in principle we can then test by setting up an experiment. And an experiment has controlled conditions. We're taking control of the situation so that we can actually see what's going on and separate out the various variables involved. And ideally we're trying to change one variable, keep everything else the same, so we can identify the effect of that particular variable. But as most of you will realize, that's ideal, and even in the natural sciences it isn't always that straightforward, less so when we come to education. So in principle what we're trying to do is have a comparison between two situations, and in one of those situations everything is kept the same apart from one variable which differs from the other situation. We might refer to the experimental condition or treatment condition compared with some kind of comparison condition. If it's a true experiment and the researchers in control of everything, then we might consider that to be a control condition, an experimental condition. But sometimes we work in education with what we call natural experiments, where the idea is we find situations that already exist, such that there's one variable which we can look at because otherwise two conditions are the same. Clearly it's rather unusual to find this, so when people find the conditions for natural experiments, they often try and take advantage of that. A trivial example of what we might mean by an experiment to test a hypothesis. One hypothesis might be that a copper wire will conduct less current for a given PD, given potential difference, if its temperature is increased. And if we consider that particular hypothesis, we can imagine someone in a laboratory somewhere with a piece of copper wire connected to some kind of power supply, making various measurements, changing the temperature of the wire, and seeing to what extent that changes the resistance of the wire, to what extent it changes the amount of current we're getting flowing. And we might ask, is this experiment really about that particular piece of copper wire? And of course, in natural science, we're very rarely just interested in one particular example of something. So we might actually think that we're not interested in a particular copper wire, but perhaps all the copper wires that exist, and that one copper wire is meant to be representative of the others. We might even think we're considering all the copper wires that could conceivably be fabricated even at some time in the distant future. So there's definitely an issue of generalization there. We might even be using the copper wire as something that represents all wires, and perhaps even representing metal in general. So generally in science, we are looking at individuals that represent wider populations. And the assumption is that we can abstract from the particular case we've looked at and generalize to a much wider class of cases. And in order to carry out an experiment, we'll need to control things. And the question comes, what do we need to control? So it's a little bit clunky this. Sometimes it doesn't move on when you ask it to. Usually we can think of all kinds of variables that we can ignore. So if we're doing research in natural sciences, it shouldn't make any difference whether the person doing the research is male or female or tall or short and so on. It shouldn't matter whether we do the research on a Monday or a Tuesday or any other day. It shouldn't matter what the researcher is wearing. It shouldn't matter whether the researcher is talking about the experiment. If you're doing an experiment with a copper sulfate crystal, it shouldn't matter to the copper sulfate crystal whether you're talking about the experiment before you actually carry it out. And it shouldn't matter what the researcher expects to happen in the experiment. Supposedly, in theory, these things are completely irrelevant and we don't have to control for these. It certainly shouldn't matter if it's windy outside. And that may not be true in some other kinds of research. I expect some of the people listening to this have been school teachers, and you may well have come across the phenomenon of the windy Thursday lunchtime. I know from my own experience teaching in a school, if it's very windy at lunchtime, and particularly on Thursday lunchtime, your class seems to change characteristic completely. Well, that shouldn't matter in the physical sciences. So you can add in any of a number of other possibilities there of variables that shouldn't really matter when we're doing physical experiments, chemistry experiments, or other scientific experiments. Clearly, sometimes this goes wrong, and that people may exclude things that they shouldn't be excluding. We might think of Fleischmann and Pons, and there are nuclear reactions in a test tube, or at least in vitro. Clearly, there were things they weren't measuring that should have been measured, so this system can go wrong. But generally, when we're doing natural science, we know there's a whole load of things that shouldn't make any difference at all. And although technically they could be considered to be variables, we can just ignore them and we don't need to control for them. But even in natural science, it's not always possible to do controlled experiments. There are some phenomena that, because of the nature of the phenomena, we can't actually set up experiments, and therefore we have to rely on other kinds of methods. So there are areas of science where primarily our research is observational, where we look at things, we measure things, we take notes about things, but we can't actually go and set up an experiment to change them. We still think that work is scientific, so scientific research doesn't always take an experimental form. So we might think that what we're doing in scientific research is trying to develop knowledge that we might consider objective, knowledge that's independent of the particular researcher who carried out the studies, and that it's research that develops an interplay between the development of theory and the development of empirical evidence that we collect during observation and or experiment. Usually that takes place within some recognized research program or paradigm or disciplinary position or whatever you want to call it. And it's also usually, if it's scientific research, adhering to certain kinds of values, that science should be open-minded, scientists should be self-critical, they should always look for alternative explanations, they should respect the data, which sometimes requires us to ignore certain results where we think things have gone wrong, but never just to exclude the data that we don't like, and recognizing that all experimentation and all observations are open to certain limitations. But what about educational research? Can we apply the scientific approach in education? Well, I think in education we're still trying to develop and disseminate knowledge, but obviously now about educational phenomena and processes. And I would suggest in particular that means teaching and learning. For sake of argument, I'm going to consider learning to be a potential for behaviour, and teaching to be activity that's intended to bring about particular learning. I'm not sure that all learning is necessarily educational in the sense it takes place in an educational context. Some learning may take place without any kind of education, and also teaching doesn't necessarily require a discrete teacher. Autodidacts maybe are people who've learned to teach themselves. But generally when we're talking about education, we're thinking of teaching and learning being connected in some way. So these two things are interacting. And of course there is research which looks at learning as a phenomenon in its own right, such as areas of psychology, cognitive science or learning sciences. And there's also research which explores the nature of teaching, but teaching and learning tend to take place within wider contexts. And in particular, we find that the different teachers have different characteristics and different learners have different characteristics, which may not always be quite so true when we're dealing with copper wires or similar physical phenomena. Every teacher is somewhat unique, and that makes research into teaching more complex. Every learner is somewhat unique, which again makes things more complicated. Because of the individuality of particular cases, there may be more problems in trying to generalize knowledge within education than there tend to be in the natural sciences. Learning commonly takes place in classrooms, not always, but teaching and learning usually takes place in some kind of classroom or proxy for a classroom. And that adds complication because we're not usually dealing with a single learner and a single teacher who are isolated in some way. And just as every teacher is unique, every learner is unique, every classroom, every learning space is somewhat unique. And classrooms occur within particular curriculum contexts. And curriculums may vary from institution to institution or country to country, and different curricula have their own qualities. So somebody learning in under a different curriculum might have different objectives, might be expected to learn in quite a different way. And the curriculum takes place within a wider institutional context, institution not necessarily just as a particular school, but the whole national institution, an education system, something like that. And of course these have different qualities as well, have different ethos. And that's embedded further in a culture, and of course every culture is unique and has its own qualities and properties. So somebody learning in a particular classroom, under a particular curriculum, in a particular education system, in a particular culture, has a lot of embeddedness. It impinges upon the way they learn, the way teaching occurs, that may not apply in many other classrooms elsewhere. And there are many different languages in the world. The key aspect of culture is language, and we know language is very, very important for learning. And clearly, if people are learning in a different cultural environment with a different language, that must have some effect on their learning. So basically, we have a very complex system. We can see that in an educational system, it might be quite difficult to identify which variables are actually relevant. So whereas we were talking about a copper wire and saying there are many things we can just ignore, such as the colour of the clothes the researcher is wearing, it may not be so obvious we'd ignore all these things in an educational situation. Even if we can identify all the relevant variables, there may be challenges of measuring them all, there may be challenges of controlling them all. And these various things may interact. So an educational process, teaching and learning, takes place within a wider system, and the various variables interact with each other in such a way that there might be synergy. This is sometimes difficult to disembed. In a particular classroom, a particular child might work as part of a small group, and the way they work in that small group is different to how they might work in another lesson where they're with a different group of children. So all these different things can affect what's going on. That may suggest that experiment isn't always the sensible approach. So if in experiment we're looking to have two conditions that are alike in every possible respect, apart from one thing we're deliberately changing, we often find in educational situations that's very difficult to do. Now, when I first started working in teacher education some years ago, and at that time a lot of my teaching was with graduate scientists who wanted to be teachers, I tended to find that they had a particular notion of what research was and what made research scientific. I actually work in an education faculty, which is very broad. It's the kind of work that goes on where I'm based. At one end, there are psychologists, for example, who are doing work which is very much in the scientific tradition of the natural sciences. And at the other end, there are people who are basically artists that are doing things that I find very difficult sometimes to even recognize as being research. I know that many of my students coming in from their degrees in chemistry and physics and biology and so on tended, when they were asked to do small-scale research projects, to think in terms of a natural science model, and that small-scale research meant a small-scale experiment. So for them, scientific research meant experimental research, and that's the kind of research you needed to do in science education. However, I'm going to suggest that that's the wrong place to draw the line. That actually, if we're thinking about the kind of research we should do in science education, we probably want to draw a distinction amongst educational research that's more in line with this notion of whether we're dealing with primarily a search for objectivity or primarily the valuing of subjectivity. There's much research that's done in education where we're seeking objective knowledge, in the sense that we're seeking knowledge that doesn't depend on the particular researcher. But there's also research in education where actually the subjectivity of different people is seen as the most important thing. And as we look at educational systems, we find that there is often great complexity, there's often great diversity, as we've mentioned, and sometimes there's reliance on intersubjectivity, which I'll come back to. And the more these features play out, the more it becomes difficult to use a natural science model in our research. Objectivity, I think, is fairly clear-cut. If I wanted to do research into the provision of laboratory equipment in school science laboratories, I could go in and count the number of beakers and count the number of Bunsen burners, and I could expect that to be reasonably objective. And other trained researchers should come up with the same answers. Subjectivity is clear from things like politics, where on a key issue, different political parties will take the same basic data, will understand them differently, interpret them differently, and come to different conclusions. And that's not because one side is inherently right and one side is inherently wrong. That's more about the fact that people with different perspectives interpret things in different ways. In some types of research, we're trying to negate that. In some areas of research, people actually welcome that. But a slightly different issue is the issue of intersubjectivity. Now, intersubjectivity is where we're actually trying to agree on things, but because people have different perspectives and different ideas, we can only find out about somebody else's thinking by actually spending some time involved with them, talking to them, trying to get a feel for what they're telling us. Especially if we come from a different background, then we might have to make some efforts to get to see things from their particular point of view. So if we were doing research, for instance, into school children's perceptions of the chemistry classroom, because we're chemistry educators, say, we may come in with a particular background, particular bias almost, that makes us see chemistry classrooms in a certain way. If we're genuinely interested in finding out how children see the classroom, we want objective knowledge about how children see the classroom, but their knowledge will be very subjective, their knowledge will be very individual. So what we need to do is to spend time trying to understand their points of view. So we require intersubjectivity to make our research as objective as possible. And I think we always have to admit that it's a fact of human nature that no matter how well we think we understand what somebody else is thinking, how well we understand what they're telling us, how much we think we understand their position, it's always possible to misinterpret. It's always possible to be wrong. So we're seeking objectivity. And we want a scientific approach, but the scientific approach doesn't necessarily mean an experiment. It means an approach that develops a research design with a methodology that works for the particular project we're working on, for the particular study. What makes sense given our particular aims, and what's possible given the thing we're actually studying. So this is in relation to our values as educators and researchers, that our desire for knowledge doesn't ride roughshod over our care for other people. It's in relation to the nature of the phenomena being studied, because if we're interested in the number of Bunsen burners in school classrooms, we can look for a certain kind of objectivity. If we're interested in the way other people understand chemistry lessons, that's a different kind of thing, and that requires different kinds of research. And it's a relationship to the kind of knowledge it's possible to have, because it's not possible to have as definitive knowledge for some kinds of phenomena as it is for others. And in technical terms, therefore, we're interested in what are sometimes called axiology, ontology, and epistemology. And often with beginning research students, they find those terms a little bit scary. But actually, it's just the things I've been talking about, and it's common sense, and we need to take those things into account. So there's a logic to developing a research design where we have concepts that come from the field, perspectives that we draw on to use in that particular research topic. We build up an understanding of the research topic that helps us develop research questions. And then given all of that, we choose an appropriate methodology to try and answer our research questions and build a research design around that. That may mean that we choose an experimental design, but only if an experimental design is sensible for that particular research study. And that may mean we're using models that come from the social sciences, not just models that come from natural science. So in the ideal of natural science, we can identify representative research subjects. So in my trivial example of trying to do research into copper wire, we can imagine a copper wire representing pieces of copper wire. We then want to isolate that research subject from any extraneous variables. So we take it to the laboratory. We do our research under clinical conditions. But in the social sciences, we're dealing with people. And sometimes it's very hard to see what we mean by representative research subjects because there is so much diversity. As we mentioned before, every learner, every teacher, every class, every classroom, every lesson, every institution is somewhat different from others. There are times when that's not a big problem for our research, but there are other times when that's something we really need to take into account. We talked about the individuality of different cases, and that may mean that sometimes we need to look for what's called analytical generalization rather than the kind of statistical generalization that's used in quantitative research. In other words, understanding examples in detail to see what they tell us that might apply to other examples, rather than just assuming that we can take a sample and then generate general knowledge from that. When we're dealing with individual professionals, teachers, for example, a teacher may be more helped by a detailed account that they can read and see if the context is similar to their own teaching context, rather than just knowing what 68% of examples led to in a statistical study. So often we might find that case studies are a more logical methodology to use to inform people than experiments, for example. Back in science, we try to isolate research subjects when we can, but social research takes place in complex settings where things are embedded in the context, and taking them out can change them significantly. So if you take the student out of the class, if you take the lesson to another place, if you take the teacher away from the department, the school, things that impact upon their work, then you get something different. You're not studying the same thing anymore. So we might need different approaches to research. Sometimes I read a lot about quantitative and qualitative research, and although those terms can be quite useful, I tend to prefer different descriptors because I think that qualitative and quantitative are used in various ways that get confusing. So one distinction is between research which is confirmatory and research which is exploratory or discovery. In one case, research is trying to test a hypothesis. In one case, research is trying to find out a good way of understanding something. Sometimes research is positivistic, which means we do think we can come to definitive knowledge about something. Sometimes research is necessarily interpretivist because we think there is no single particular viewpoint to be understood, and that we therefore need to understand how particular people in particular perspectives look at things. Sometimes it makes sense that our research is nomothetic, which means we're looking for laws, we're looking for what's typical, we're looking for general situations. But other times it makes sense to look at the individual and do ideographic research. And it's not that one of those strands is better than the other strand, or one of those strands is more scientific than the other strand. It's that different studies call for a different kind of approach, because A, we might have different kinds of research questions, and B, we might have a different background that sets out a different level of understanding as a starting point. The most obvious one is perhaps the difference between the discovery approach and the confirmatory approach, which is largely tied to whether our research is inductive or our research is deductive. Are we able to set up a conceptualization to test that lets us measure particular things, or are we needing to undertake observations that will allow us to develop a new conceptualization? And often in research, what we're really doing is move backwards and forwards between those two positions. So overall in research, we need different kinds of studies. And sometimes we need in-depth studies of individual learners, in-depth studies of individual teachers, in-depth studies of individual classrooms. And then we might take ideas from that to do surveys of wider populations. And then when we're confident, we might want to actually then move to a situation where we do something that's more like an experimental test. But that may only come later when we feel we've already done a lot of groundwork. And in this talk, I'm particularly focusing on some of the limitations of experimental research, but all types of research have limitations, all types have their strengths and weaknesses. As far as experimenting is concerned, it's probably only the meaningful thing to do if we can control the variables that are important, and we can do that while studying a phenomenon that's embedded in its natural context, or by taking it out in a way which doesn't fundamentally change it. But as I've said just now, in education, it's often the case that if we do disembed something, we've no longer got the very thing we were trying to look at. And that raises the question of how we can move from the particular to the general, because a lot of our research is theory directed. The exception to that will be research that's carried out by individual teachers in many classrooms. So if you're a teacher in a classroom, you might do what's better labelled as context-directed research. You may have a problem that this particular class doesn't seem to understand this particular concept, even though you've taught it to them very well, or you think you have. You may have a problem this particular class does not seem to have any interest in this particular topic and they just won't engage. If you're doing context-directed research, what matters to you is finding a solution that will solve the problem with that particular class. It may well be that what you find out can be transferred to other classes, other institutions, but that's not the primary point. So for individual teachers working in individual classrooms, it sometimes doesn't matter whether their findings are generalizable. But for people who are actually doing theory-directed research, and that applies, for instance, to people usually if they're writing a thesis, and certainly if they're writing for the main educational journals for publication, doing projects for research councils, funded research, then they're trying to develop theory. And when you're trying to develop theory, you start from ideas that are theoretical, you set up your research questions, then you move to a specific educational context where you'll carry out your research, you'll develop some knowledge of that context, but it's not the knowledge of that context that's important, but how you then generalize from that context back to a general theoretical situation that can apply in other contexts. So that's a big challenge for research in the social sciences. And this links to two different types of sampling. So the kind of sampling that's often common from scientific research is what's sometimes called statistical sampling, where if you know your copper wire may not be the same as all other copper wires, perhaps you can collect a large statistically significant sample that's representative of all copper wires and test those. And we might think that in education, how can we do something like that? So if you wanted to make a general statement about 16-year-olds, for example, or specialist chemistry teachers working in Scotland, for example, or students taking international baccalaureate chemistry, for example, how would you get a random representative sample of those? How would you get a sample that was either random or representative of such populations? But that's not the only way to get a sample. And in some types of research, it makes more sense to deliberately select your participants because you know they might be particularly informative, even if they're not especially representative. Now, if we're doing experimental research, we need to use the statistical approach. Whereas if we're doing something like case study, it may make sense not to go for the typical, but to go for the examples that we know are going to be informative. So we require a statistical sample if we're going to generalize our results using statistics, and we want to be able to take those results from a particular context and make it more general. But this requires randomization unless we have some other way of getting a representative sample. And in order to get randomization, we need to be able to identify everybody in the population and make sure that each member of the population has an equal chance of being selected. So if you think about 16-year-olds or specialist chemistry teachers in Scotland or students taking international baccalaureate chemistry, I don't know how many specialist chemistry teachers there are in Scotland, but if I wanted a random sample of, say, 1 in 100, I'd need to be able to identify all those teachers and have a way of picking out at random 100 of them. And there are ways of randomizing, such as picking names out of a hat. But surprisingly, when people do randomization, sometimes they can't tell you how they've done it. And this makes me very suspicious as an editor. If authors tell me that they've randomly assigned participants to the conditions, for example, and I say, well, how did you do that? And they can't answer that question, I suspect they haven't actually used randomness at all, and they've just done it in an arbitrary way. That doesn't count as random. With our random sample, we can use statistical inference, which means we can infer from what happens with the sample what should be the case with the general population. But there are, of course, limits to statistical inference. Typically, if we get a result with a probability that's no greater than 1 in 20, we consider that result to be statistically significant. If the result is greater than 1 in 20, we consider that to be non-significant. But the result that's statistically significant may not be important, so we might also need to look for something like effect sizes. And we can get a result that's only going to happen once in 20 times just by luck. And something that happens more often than 1 time in 20 could still be quite unlikely. It's just not that unlikely. So it may still be a significant result, or a real result that hasn't reached significance. So there are limitations to statistics. Whenever we use statistical tests, are open to getting these kind of errors, false positives and false negatives. We could always change our probability value using the cutoff. If we move it in one direction, we find we're more likely to get one kind of error. And if we move it in the other direction, we find we're more likely to get the other kind of error. There's no perfect answer to that. Despite that, studies that use statistics are considered to be the gold standard, particularly when they use large-scale field trials. This is the kind of thing that the UK government has tried to suggest to be used more in educational research. Such field trials are used when testing drugs, for example, but they use double blind, which means that in a drugs test, a drug trial, a placebo is used. Nobody knows who gets the placebo. People in the conditions don't know if they're in the experimental condition or the control condition, and the actual doctors giving out tablets don't know when they're giving out the drugs, when they're giving out placebo. Very difficult to see how you can do that in education. We have a problem there. We have a problem of trying to assign our control group and our experimental group to make sure they're equivalent in some way, particularly if we can't randomize. Maybe we can try and match in some other way, but then we have to know what we're matching. Maybe if the two groups are not the same, we can use mathematical models. But that gets difficult. I know from experience of having been involved in a study that used that kind of effect. These are results from a real study, and the blue arrows show the movement of average test scores of classes that were learning a topic in their usual way, and the red show the movement in average test scores for classes that were using an apparently supposedly innovative treatment. And the only way to find out whether that's statistically significant or not is to do some complicated stats where decisions have to be made about how the data is treated. It isn't that straightforward. So there are complications in doing this kind of research. One complication is the effect of practice on teaching. Most of us who teach know that when we teach something the second, third, fourth, fifth time, we actually usually get better at it. We make less mistakes. We become more fluid. When we teach something the first time, there can be slip-ups. In the study I just mentioned, we were comparing people teaching a new scheme for the first time with people who were teaching a scheme that was familiar to them. That, I think, is a factor that needs to be considered. We also have to wonder when it's sensible to ask people to teach something in a novel way, given that they are likely to make slip-ups. So we haven't got a fair comparison if in the experiment people are doing something that they haven't practiced, and if in the control they're doing something that they have practiced. There are also novelty effects. If we're distilling a mixture and then we mix it up again and distill it again, it shouldn't matter to the mixture that it's already been through the process. But human beings notice novelty. We notice things that stand out. So when children are taught in an unusual way, that tends to have an effect, good or bad. So again, whenever there's novelty, that's going to mess up our experiment because we've got a novelty difference as well as the thing we're trying to change. There are also expectancy effects. A very famous effect is the Pygmalion effect. This was originally demonstrated by some researchers who went into a school with an instrument that could, or they suspected, could indicate which of the students in the school were likely to make good progress in the following year. They tested the children, and then from their instrument they were able to tell the teachers which of the children they thought were going to make the best progress the following year. They later went back to test that, and they found that the instrument was successful, that it could statistically predict which children were going to make good progress the following year. Except, of course, it was a sham. they randomly assigned children to this condition. So they told the teachers certain children were expected to make progress, and that was purely a random assignment. Despite that, the children who were identified as expected to make progress made more progress. So if a researcher expects something to happen, or a teacher expects something to happen, there's a higher possibility it will happen just based on expectancy. And clearly that works the other way as well. And I remember a project I was doing where I was trying to develop an after-school enrichment program for gifted students. And one of the local heads of science, when I talked about the gifted students in science at their school, told me they didn't have any gifted students in science at their school. And I suspect if they thought like that, it was probably true. So we get these self-fulfilling prophecies, which can be good or bad. We get these feedback cycles where one thing influences another, and the very thing we're trying to change is actually changed by the whole process of measuring it and looking at it and thinking about it. So where people have expectations about the outcome of an experiment, that will undermine the experiment again. That raises one question about whether it's better to, if you're comparing a condition between two different classes, as sometimes happens in some studies, should it be the same teacher who teaches both conditions? And I don't really have an answer to that, because if you have a different teacher in the different classes, they're a different teacher. If you have the same teacher, are they likely to be equally skilled and have the same expectations of both approaches? Probably not. There are big ethics with using experimental research, big ethical considerations. We shouldn't disadvantage people because they're involved in a study. So we shouldn't put people into an experimental condition if we have good grounds, if we don't have good grounds to believe it might be effective. Perhaps because people have done action research, which is a kind of research where they can stop the research as soon as there are signs things are going wrong. And if action research suggests something should be useful, maybe we can then test it in better experimental conditions. We also shouldn't put people into control conditions that we think are going to disadvantage them. So we should really only use experimental tests when we're fairly confident that the two conditions are equally likely to be effective. If we believe that the experimental condition is likely to be more effective, it's not really fair on the control condition, and vice versa. So only when we're not really sure what's going on does that kind of approach make ethical sense. That's not to say we should never test things, but we shouldn't go around testing things if we've already got very strong reasons to believe they will or won't work. And that brings me to a point about what I call 3 different levels of experiments. And these 3 levels relate to the kind of control that's used. There are some experiments used in education which don't use any control at all. There are some which try and test an innovation against a standard treatment, and some which try and test an innovation against what we might call enhanced treatments. And as an example of the first type, I refer to a study where they wanted to see if a program about floating and sinking could help young children to develop their conceptual understanding. And they compared children who had the program with children who weren't taught anything about the topic and whose teachers were told they shouldn't teach them anything about the topic. And that might seem a rather weak kind of study, because if you're comparing children that have been taught with children that haven't been taught, you might think it's pretty obvious that children that have been taught should do better. However, their logic here was that the theory that was generally accepted suggested children of this age were too young to understand the topic. So given that consideration, it made sense to do a comparison with students who weren't taught anything. They needed to have some sort of comparison because young children were developing anyway, and for all they knew, the children might have been developing to the same level even without an intervention. or perhaps the intervention may have even retarded their development. So you have to have some kind of comparison. You need to do a pre-test and a post-test to see if there's been a change. And of course, the pre-test itself can act as a learning experience, another complication of experiments. So quite possibly a pre-test could have an effect, even if there was no post-test. So even if there was no intervention. Another complication with pre-tests and post-tests is that often people will say, well, there was no significant difference between the two groups before, and there was a significant difference afterwards. And I'm not always convinced that that's the right measure to see if there's been any change, because one can imagine situations where differences before an experiment just turn out to be non-significant, and differences afterwards just turn out to be significant. So I think we need to actually be testing before, not to see if there's a statistically significant difference, but to look at the other end of the distribution curve and see just how similar things are. So look at the other tail of the distribution. Slightly above my level one is a study here where they wanted to do some additional sex education, and they compared classes that had their normal sex education with classes that had an additional special lesson to see if that had an effect. Interestingly, one of the research questions referred to whether this would have any effect on the children's behaviour, and they didn't actually test that, which perhaps is just as well, but it seemed to get through and be published in a decent journal, even though one of the research questions in the publication isn't addressed at all. A level 2 test, a level 2 experiment, would be examples such as this, where students were taught biology in a productive way, but the experimental group had some additional activity that the main group didn't have. But there are some kinds of level 2 experiments that I think are very questionable on ethical grounds. So I've seen quite a few studies like this, where it talks about the fact that we know that children learn best in certain situations. Let's set up a situation like that, and let's compare it with students who aren't in that situation. So we get a control group with teacher-centered, didactic lectures, not allowed to ask questions, or not expected to ask questions, not allowed to use resources, and basically being taught in a way that most of us would recognise as rather unproductive. And I wonder about how we can do research where we say, as part of our research, that we know a certain type of learning is beneficial to students, and we deliberately set up some of the students to have learning that doesn't have those benefits, because that doesn't seem very good research. We're checking for things we think we already know, and we seem to be discriminating against some students. And the justification I see for that is, well, actually, these students will have normally been taught in that rather unexciting way anyway. Which is worrying in itself, because what we seem to be saying is that we keep on doing this research, and it keeps on telling us a certain type of teaching is more effective, but the research has no effect because teachers don't teach that way. My final example is of what I call a level 3 experiment, and here the experimental group does something different, does something special. In this case, it was formative assessments, but the control group does something else. In this case, they got more of the same, but they got more of some productive things that were known to be useful. So in this particular study, the researchers are comparing something a little bit different, but with some extra of something that's already believed to be good. So we're comparing an innovation with something that we already consider is good practice. And I think that solves some of the ethical problems we see in some other types of experiment. So we need to think very carefully about when it's appropriate to use experiments. If we are trying to test hypotheses, if we can get the right kind of samples, if we are able to randomize, if it is ethically appropriate to use control groups and to ask people to undertake innovations, if the people involved aren't aware whether they're in a control group or an experimental group, which admittedly seems quite unlikely, and if the people doing the scoring aren't aware who's in which condition, we probably have the ideal situation for experiments, but actually we very, very rarely have anything like that in educational research. So basically, in education, we're doing something that's very complicated. We're dealing with very complicated phenomena. And we want to use scientific research, research that uses appropriate methods, research that's feasible. And there is a place for experimental methodology when it's justifiable. But often the things we're trying to look at make doing experiments just non-feasible. We just can't set up the conditions for a meaningful experiment. Okay, now that might sound like I've got it in for experiments. I haven't, but I read a lot of experiments in the literature, and sometimes I do wonder if we're sometimes doing experiments just because we're scientists and that's what scientists do. Thank you all very much.
Thank you, Keith. Are you able to hear me?
Yes, I can hear you, Michael.
Great. So thank you very much. What I'll do now is I'll just try and compile some of the questions that have come through. I mean, I suppose just one general one that's I've been thinking about is this issue about very often people will have a study that they do in their own context. And there's this issue of moving that from that individual context to generalizable. And I remember Diane Bunce talking about one time that a study in a particular context within a particular theoretical framework is like one lamp, and that published connected with other studies within similar theoretical frameworks under similar conditions or similar types of approaches are other lamps, and by combination of various approaches, various results, they all point in one direction. So I'm just wondering about this issue of moving from an individual context to generalizable. Do you still consider that to be a valid output, that somebody has a result and has a kind of an output from their own experiment? How do we move that towards some sense of generalizability? That's a sort of a very vague, overarching question while I compiled some that have been asked.
Yeah, I mean, I think that's perfectly reasonable. I mean, if somebody does a study in a particular context, whether it's an experimental study or some other kind of study, then they found out something about that context. If somebody does a similar study in a somewhat different context, if they're getting comparable results, then that tells us a little bit more than the individual studies. If quite a few people have done similar studies in a wide range of different contexts, and they're finding they're getting very comparable results, then we start to have a little bit more confidence that we've got something that's generalizable. But you know, we can never really be certain how generalizable things are. So it is a question of always being critical, being aware of the fact that it's a bit like a thing about the swans. You know, the old idea about the swans that you know, if you go out and you see swans, they're all white. How many swans do you have to see before you can say, well, all swans are white? And logically, you have to see all swans. But in practice, you know, we can start being quite confident if we've seen hundreds of swans and never seen one that's not white. I think historically that example used to be used before people went to Australia and found black swans. So it's quite an interesting example. But
yeah, I mean, Ron Blonder just mentioned there, of course, meta-analysis is I suppose the formal approach to that. Ira asked about you had been talking a lot about different experimental designs and the issues with them. From your own perspective, what do you consider to be innovative research designs that we might see in the future? What kind of directions are people taking that are interesting to you?
Are we still talking about experiments?
Yeah.
I mean, I think experiments are perfectly valid if you can actually set up a reasonable level of control, or you can measure something in a way that it's not influenced by lots of variables that you're not able to identify or measure or control. And I think there is a place for experimental studies. I think the ethical issues are important though. So if there's an innovation that you have good reason to think might be effective, but you genuinely don't know if it will work in a particular situation. And if you're comparing it with something which is reasonable practice, then I think that's perfectly ethically okay. If you have something that you have good reason to think should be extra special, then I think you need to compare it against very good practice, because that's, then you should be judging it against people who are getting something that's good practice, and not against your bog standard practice. So I think it's a question of thinking about setting up an experiment so that you can genuinely say you don't know what the outcome's going to be. And I think of some of the experiments that I see published, it would be amazing if they didn't get the results they're expecting. Because they'll say things like, well, somebody's done this type of teaching and learning when they're teaching rates of reaction with 14-year-olds, but they haven't done it with, I don't know, they haven't done it with oxidation with 14-year-olds, and they're going to try it with oxidation with 14-year-olds. And I think in that situation, to set that up with a control group that you deliberately teach in a kind of substandard way is totally unacceptable.
Yeah,
in terms more generally, I think. Sorry,
I was just going to say. I
think that's your problem. That you're.
No, I was just going to say. I think I remember you. I think it was you actually speaking in the summer, mentioned this issue about ethically comparing outputs of an innovative approach with something, and the need to compare that with something that we know works well, rather than something that is not considered to be a sort of an innovative or a good approach. So in other words, when we're saying something is better, what are we saying it is better than?
That's right. So I think we shouldn't be setting up an experimental condition unless we've already got good grounds to think that the experimental condition is going to be positive for the people involved. And we shouldn't be setting up a control condition that's deliberately detrimental to people. So a good experiment has an experimental condition of something that we've got good reason to think would work, and we're comparing it against something that we already believe works well. And I think then we're doing something that's in everybody's advantage.
The next question then Jeremy asked, and Jeremy might type in case I get it wrong, but it was a question about the possibility of delayed treatment controls. I'm not quite sure, Jeremy, whether you're able to type in there. Just essentially, what about delayed treatment controls? Let's see if
is that in the sense of deferred tests?
Yes.
I mean,
just wondering how ethical Keith thinks they are.
I'm not. Can you just explain, Jeremy? Can you just explain what you mean by that term? Because I thought you meant doing a post-test sometime after the end of the intervention, but I don't think that's what you mean. What do you mean? Can you type in what you mean?
I think he's going to type now. Yeah.
Okay.
And I think that was another question while Jeremy's typing is what if we can't or don't randomize? Does that raise issues regards to, I mean, you obviously, I know, have strong feelings about randomization. What if randomizing isn't possible?
Well, I think that's okay if you are confident that you have comparability between the two groups. But it's very difficult to know what comparability is, because again, it goes back to how do you know which variables you need to check for. If you've got two groups that seem very similar but slightly different, how do you know if that slight difference is a difference to be of concern? So I think there are all these issues. And again, it doesn't mean we shouldn't do experimental research, but because it's so complicated, there's lots of things we need to think about. Going back to Jeremy's point, yes, I think what Jeremy was saying was, what about when you do an intervention and you have a control group, and then later on you give the control group the intervention? And I think that can certainly help with some of these ethical issues, but you still shouldn't be deliberately setting up the control group to be taught in a way which isn't very effective. So if you've got a class that's being taught reasonably well as a control group, they're getting a decent instruction as a control group, and then later on you give them the intervention that they missed out on because another group was the experimental group, then I think that certainly helps, yes.
Yeah. Okay, we are pretty much up on time, so I would just like to thanks very much, Keith. Thanks very much for your webinar, and I'm definitely going to have to go away now and read a lot more about experimental approaches. You had a lot of references in your presentation, and some of them may not be visible, so I might get some of those off you, and I'll paste it under the video when I post the link. Just to mention that after the break, our next webinar in the series will be with Nathan Grove, who does really interesting stuff for cognitive science in considering how to measure cognitive load in teaching and what that means in terms of teaching strategies. So that'll be on 24th of January. And until then, I wish you all very well. And just to say thanks again, Keith, for your time and expertise as always. Very much. And best wishes to everybody. I hope to have the recording up on our group website as soon as I download it from the server. It can take a few days. So thanks to all for listening and tuning in, and all the best. Take care.
Bye-bye.